In order to understand the concept of interference, let's back up to the concept of the principle of superposition. And that just simply states that if you have two waves that overlap, they just add together. They superpose. Literally, that's what superpose means, one on top of the other. An example of this, if I'm trying to teach class and somebody else is talking, you can hear both of those things at the same time, right? If I shine a flashlight across the room and the light is shining down from the top of the room, the light from the top of the room shines right through the flashlight beam. The flashlight beams don't cast a shadow, right? This is obvious, right? If you throw two stones in a pond, you'll get these ripples that overlap. And there's some really good videos of this thing. Now notice that, by the way, there's some places where the water is relatively flat because of the overlap, and places where it's actually a much higher amplitude, like two crests meet and make a super crest, right? And that's the fun stuff, right? Now, there's two different types of interference that we're going to deal with, and we'll do a little lab on this. Destructive interference is when you superpose an up pulse and a down pulse, and at this moment you'll have they'll overlap precisely, right? And then where did the energy go? If this is potential energy, right, then here we must have super high kinetic energy. That is, this spring must be moving up and that down, right? Here we've got two up pulses colliding and creating a super up pulse, okay? And look, I guys have to show you this video. We will do this lab. We'll do this out in the hall, okay? But check, oh, not that one. This guy, check this out. And the music is good too. So this is the first one you'll see is constructive interference. Notice it misses these cups, right? Boom, nails that one, right? We have to do this. Okay, and the next one you're going to see is destructive interference, right? It's not going to hit this cup, but it will hit this cup, but it will pass through these without hurting them. Isn't that cool? So precisely at that moment, right, that's destructive interference. Now, if you're wondering how those noise-canceling headphones work, whoa, baby, let's pause you. Those noise-canceling headphones work that same way, right? Here's where your eardrum is. Sound from, maybe this is sound from the outside. The speaker next to your ear actually creates the opposite pulse of that, right? And so when it passes by your eardrum, at that moment, it actually just cancels out. We'll do this. We'll actually do this in the hallway outside the room here. Here's another one. This is kind of a slow-mo picture. I like this one. Watch these guys, right? Notice they've got tape marks for how far out they're going to move their hands. Whoa, super big, right? It's kind of fun. What is this on the floor there? I don't even know. Is that just a spot on the floor with different tile? I guess that's what it is. That's kind of cool, isn't it? You can see the reflections off their hands too, right? All right. Now let's escape from that. Let's go back to... All right, so that's the technology behind noise-canceling headphones. Now, the general rule is this. If crest meets crest, you get constructive interference. If crest meets trough, you get destructive interference. And there's a rule about the phase of this, and this is how many wavelengths difference, right? But if you look at this, this is, if you have source A and source B, and they're actually exactly in synchrony, then you'll get this super loud sound, right? If you have speaker A and speaker B, right, if this is your right channel, this is your left channel, right, and you hook them backwards, that is, you hook one speaker backwards with respect to the other, then when one speaker is moving out, the other speaker is going to move in, and they'll actually cancel out. So that's why speakers have a red and a black connector on the back, so that you connect them the correct way. You want to hear a maximum amount of sound, you don't want to hear nothing, right? Okay, so when you hook up stereos, the speakers don't really care which terminal they're attached to, but you have to hook them the same way or you'll get destructive interference, which would be bad. Okay, if you look at this, the rule is that we have there's a half wavelength difference, okay, with this. So let's look at this. This is A and B are the same distance, and I'll do this demonstration in class. If I slide B out a whole wavelength, we'll also get constructive interference. If I slide it 2 wavelengths, I'll get constructive interference. In general, if it's an integer number of wavelengths, then we get constructive interference. If I take B and slide it a half a centimeter, or a half a wavelength forward, or slide A half a wavelength back, now we get destructive interference. And I'll show you this, okay? This is a demonstration there. And then also, if I have two speakers generating the same sound at the same time, we ought to be able to walk around the room and find places where we are, in each instance, right? We are, say right here, we are some distance from this source and some distance from that source. If this is an even number of wavelengths difference, then we get constructive interference. And if it's a half number of wavelengths difference, right? Like here, by the way, I'm 1, 2.5 from here, but I'm exactly 1, 2, 3, 4 from there, right? Okay, this would be actually destructive interference right there. This thing here would be constructive interference. We will hear that. We're not going to actually do the math of this. I'm just going to have you guys walk around the room, and we're going to create little pockets of anti-sound with speakers. Okay, and then even cooler than that is that we can actually do this with light, which is a cool thing. And I'll demonstrate this right now. I don't have two speakers that can create light, or I don't have two emitters of light that can create light, just like I can do with sound. But what I can do is I can shine a laser beam on a couple narrow slits. The light will spread out from those slits, and those will act like two speakers. On the screen that's far away, we'll actually see a series of bright and dark spots. And that's that laser light constructively and destructively interfering. Anyway, that's super cool. I'll show you this, okay?